So, I see there that you found a rock. Yeah, what about it? Would you like to know how to identify that rock? I mean, I guess I'm curious, but where would I even start? That's what I'm here for. Hi, my name is Miss Hammerlund. Recently, I've been learning how to figure out what different rocks are out there. Since you're here and you have a rock, I'm going to walk you through the process and tell you all what I learned. I mean, you're a complete stranger, but what have I got to lose? Take my rock. You know what? I'm not just going to identify this for you. There's so much we need to know. I'm going to walk you through how we can figure out what this is. Sound good? I really don't know what choice I have, so what the heck? Alrighty, Babs. Let's start off by defining rocks and minerals. Aren't rocks made of minerals? You are one smart bird. Well, yeah, I'm a corvid. True, but back on topic. Minerals occur in nature. They have very distinct properties, both physical and chemical. Rocks are made up of more than one kind of mineral. Geologic processes mix them all together. It's science. All right, cool. We have ways to classify both rocks and minerals. Let's start with minerals, because after all, they're the foundation for rocks. We have a few tools to use to classify minerals. We can learn through mineral properties, crystal systems, and chemical composition. Okay, can you speak English, please? Don't worry, let me explain. Chemical composition is one of the main ways we find out what type of mineral we are looking at. Simply put, composition means what the mineral consists of. Is there sulfur? Is there carbonates? Can we find any chlorine or fluorine? Dude. Sorry. That's not the only way either. Mineral properties are much easier for an average Joe to test out. What color is it? What are the crystals like? How does it break? Does it streak when you scrape it across a hard surface? And what color is that streak? Can you attract this mineral with a magnet? How hard is it? There's a whole list of tests. Okay, wow, you are strange. Well, I may be strange, but do you know what isn't? Crystal systems. These are patterns in which crystals, which make up the mineral, are arranged. These are determined at the atomic level. Neat, huh? Okay, that actually is kind of neat. I'm probably going to regret asking this, but what about rocks? There are different kinds of rocks, but that shouldn't be a shock. There are three broad categories of rocks: sedimentary, igneous, and metamorphic. What the heck are you squawking about? Let's keep it simple. Sedimentary rocks are formed from hardened sediments like sand and silt. Igneous rocks are formed by cool magma. Metamorphic rocks are rocks that were changed by intense heat and pressure that you and I could never even imagine. You know, looking at your rock, based on the presence of quartz crystals and just the general appearance, I'd say we have a sedimentary rock. Okay, for a crazy person, you do know something. Just out of curiosity, are the tools for rocks and minerals the same? Is it different, or how does that work? Great question there, my friend. It's actually a little bit different depending on the rock. Let's start off with sedimentary rocks like what we have here. These are classified based on what makes them up, the size of the sediments, and whether or not they are clastic. Clastic? Don't you mean classic? And how does that word apply to rocks? Clastic, not classic. Clastic means that the rock is made up of parts of older rocks. Ah, okay, that makes more sense than classic. That's neat. Isn't it? Where and how a sedimentary rock formed is also important. Limestone, for instance, is formed in marine waters. That's what I believe you have here. All right, this is more interesting than I thought. What about igneous rocks? Ah, yes, the volcano rocks. These rocks are classified based on grade size, composition, texture, and where they were formed. Extrusive igneous rocks, like basalt, are formed on the Earth's surface, while intrusive igneous rocks, like granite, form inside the Earth. These rocks even cool at different rates, which aids in their diversity. Oh wow, I guess I shouldn't take that for granted. What about metamorphic rocks? See, you're catching on. Metamorphic rocks are classified as foliated or non-foliated. Foliated rocks have aligned crystals, while non-foliated ones do not. And let's not forget the importance of texture and composition, just like other rocks. Quartzite is an example of a non-foliated rock, and schist is a foliated one. Holy schist! Thank you for this. I wasn't expecting to be interested in rocks of all things, but I learned a lot. And you're weird, but you know your stuff, so you're pretty cool. Now, well, it's my pleasure. Fly on by anytime.